Hello everyone, I am Amit Maru and today in this video we are going to discuss about assembly line scheduling. It is a problem of automobile manufacturing company and it is also the topic of dynamic programming of analysis and design of algorithm subject. So let us start our today's video on assembly line scheduling. First of all, let us have introduction of assembly line scheduling, or we can say what is assembly line scheduling is. Assembly line scheduling is an example of dynamic programming solves a manufacturing problem. One company produces automobiles in a factory that has a two assembly line. An automobile chassis enter, each assembly line has a parts added to it at the number of stations and a finished auto exists at the end of the line. So for example, one company has a different two assembly line. So first of all, you must understand what is assembly line is. Suppose this is the assembly line. This assembly line has a two gate, one is entry gate and second one is exit gate. Inside this assembly line there will be number of stations. For example, station number 1, station number 2, station number 3 and station number 4. All the stations are basically used to assemble some parts of our automobile. For example, this assembly line is for the assembly line of any car manufacturing company. Then in the entry gate we have to pass one skeleton of our car, and all the stations will add different parts of our car. Suppose we have passed a skeleton of car to station number 1. So station number 1 will add different parts to our car, and it required some time to assemble these parts. Suppose it required a 5 unit of time to assemble some part inside our skeleton of car. Then we'll pass to the station number 2. Station number 2 will add another part to our car, and it required, for example, 9 unit of time. Then we'll pass to the station number 3. Station number 3 will add remaining other parts and it required, for example, 7 unit of time. And then we'll pass to the last station, that is station number 4. Station number 4 will add remaining all the parts and it required, for example, 10 unit of time. And after this station number 4, at the end of this assembly line, or we can say at the exit gate, we can have a full finished car. This is simply known as assembly line scheduling, and total time required by this assembly line is suppose 31 unit. So this is all about what is assembly line. Now let us understand what is problem is. The manufacturing company produces automobile in a factory that has a two assembly lines shown in below figure. For example, this is the assembly line number 1 and this is assembly line number 2. As we discuss, assembly line basically used to add different parts to our skeleton of car and have a number of stations. For example, assembly line 1 has a station number 1 and it required 7 unit of time. Station number 2 required 9 unit of time. Like that, total of 5 different stations are there, and every station required some unit of time. Same way, line number 2, assembly line number 2 also has a different 5 stations. Station number 1 required 8 unit of time, station number 2 required 5 unit of time. Like that, station number 5 required 5 unit of time. One thing you need to note it down here is we have a two different assembly line, but station of assembly line 1 for example is used to add some parts. Then station number 1 of line number 2 will also add same parts, right? So either you can choose station number 1 of line number 1 or station number 1 of line number 2. Same way, for example, station number 2 basically used to add the engine to our car. Then station number 2 of line number 2 also will add engine to our car. It means that the work of every station is fixed, whether it is a line number 1 or line number 2. So we have freedom, either we can pass our skeleton to station number 1 of line number 1 or station number 1 of line number 2. As per our requirement, we can pass anywhere, but our goal is we have to pass our skeleton to each and every station, whether it is a line number 1 or line number 2. Whenever it is required, you can change line number 1 to line number 2 or line number 2 to line number 1 as per your requirement. Now, what is exactly the problem? The problem here is what situation should be chosen from the line number 1 and which from the line number 2 in order to minimize the total time through the factory for one car. It means that, as we discussed, we have freedom that we can change our line from 1 to 2 or 2 to 1 as per our requirement. But now our basic goal is we have to reduce total amount of time to produce one car. So for example, station number 1 required minimum time as compared to station number 1 of line number 2, then definitely we have to pass our skeleton first to station number 1 of line number 1. Now we have to pass our car to station number 2. So now we have two options. We can use station number 2 of line number 1 or line number 2. As we discuss, station 2 of line number 1 and line number 2 both has the same work. So either we can choose this station, that is the station number 2 of line 1, or this station, this is the station number 2 of line 2. Now we have to check the required time for both the station. Here station number 2 of line number 1 required 9 unit of time, and station number 2 of line number 2 required 5 unit of time, which is less than the 9. So definitely we have to choose our line number 2 and station number 2. So we have to move from station number 1 to the station number 2 of line number 2. Now another thing is, when we move from one line to another line, at that time it required some time, and this time is known as the T time. For example, it required 2 unit of extra time because we are moving from one assembly line to another assembly line. If you are moving from same assembly line one station to another station, at the time it is a ignorable time, so it not required extra time. But when we move from one assembly line to another assembly line, either from 1 to 2 or 2 to 1, at the time it required some extra time, and this extra time is known as T time. Right, when we move from one assembly line to another assembly line. So now our goal is we have to choose one path from entry gate to the exit gate. In between you can choose any station of line number 1 or line number 2, and we have to make one path which required minimum amount of time to make one car. This is the goal, and this problem is known as assembly line scheduling problem. Let us solve this problem by using a different method. First one is a brute force method. In a brute force method, enumerate all the possibilities of selecting stations. Then compute how long it takes in each case and choose the best one. So as we know that in every station we have a different two options. Either we can choose line number 1 or line number 2. Right, so we have to check all the possibilities, and at the end we have to identify which possible path required less amount of time. But when we think about the solution by using brute force method, suppose if we say that 0 is choosing for the line number 2 and 1 is choosing for the line number 1, and every time in every station we have two options, either we can choose line number 1 or line number 2. So total 2 raised to n number of possibilities are there. So whenever the value of n is very large, at that time this is not the feasible solution, because it has a 2 raised to n different possibilities, and among this possibility we have to identify the path which required minimum amount of time. So this is not the feasible solution, so we must have another solution, and another solution that is by using dynamic programming. So let us discuss how we can solve same problem by using dynamic programming. As you know that in dynamic programming we have to define one matrix. So here also we have to define one matrix which has a size capital N number of rows and capital S number of columns. Here capital N is nothing but number of assembly lines. If 2 assembly line, it means that total 2 number of rows will be there. And S number of stations, for example 5 number of stations, then there will be 5 number of columns. So 2 number of assembly lines and 5 number of stations, for example, then number of rows will be 2 and number of columns will be 5. So 2 by 5 matrix will be there. So first step is we have to make one matrix. Now we have to fill this matrix by using different two equations. This is the equation number 1 for the assembly line 1, and this equation is for the assembly line 2. As per this equation, we have to fill our matrix, and from this matrix we can get a solution, or we can find the path which required minimum amount of time to produce one car. So let us take one example. Suppose we have a two assembly line. This is assembly line number 1 and this is assembly line number 2. So as you know that assembly line has a different stations. So station number 1, 2, 3, 4 and 5. So 5 number of stations in our assembly line 1 and 5 number of stations in our assembly line 2. We have a two entry gate. One is entry gate for the station number 1. It required 2 amount of time, and entry gate 2, this is the entry gate of our assembly line 2, and it required 4 unit of time. Likewise, we have a 2 exit gate. This is the x1 is exit gate if we are coming from the assembly line 1, and it required 3 unit of time. This is the exit gate, that is x2, and it required 6 unit of time if we coming from the line number 2. So we have a 2 entry gate and 2 exit gate, and at the end of this assembly line, where you can say either we can choose x1 or x2, we can have a full finished car. Right now, as we discussed, we have to identify the path which required minimum amount of time to produce one car, and we already discussed that we have to make one matrix, and the matrix size depends on number of lines and number of stations. Here total 2 number of assembly lines are there. This is assembly line 1 and assembly line 2. So total number of rows will be 2. This is the first row and this is the second row. This first row for the assembly line 1 and second row for the assembly line 2. Then how many number of columns are there? It depends on number of stations. Station 1, station 2, station 3, station 4 and station 5. Total 5 number of stations are there in both the assembly line. So total 5 number of stations, so we can say 5 number of columns will be there. So 2 by 5 matrix is there. Now we have to fill this matrix by using this equation. This equation number 1, that is for the assembly line 1, and this second equation for the assembly line 2. So let us fill this matrix by using above both the equation. Now for example, at the entry we have 2 options. Either we can choose E1 or E2. If you want to move from assembly line number 1, at that time definitely we have to choose E1. If you want to move to the assembly line 2, at that time definitely we have to choose E2. So now it is depends on you whether we have to choose assembly line 1 or assembly line 2. But now you have to choose assembly line 1 or 2 based on the required amount of time, which required minimum amount of time. Based on that, you have to choose either gate 1 or gate 2 or E1 or E2. Now let us check. For example, if we choose E1, at that time we will move to the assembly line number 1 and station number 1. If we are on station number 1, at that time required time for the station number 1 is 7 and required time for our entry gate, that is 2. So 2 plus 7 is equal to 9. So when we move on station number 1, at that time required time for the station number 1 of line number 1 is 9. Now when we move on station number 1 of line number 2, at that time definitely we have to choose E2 gate, or we can say entry gate 2, and it required 4 unit of time. So 4 plus 8, total 12 amount of time, or 12 unit of time required if we choose station number 1 of line number 2. So initially we have a 2 equation, E1 plus A11 and E2 plus A21. If the value of j is equal to 1, j indicates our station number. When the station number 1, at that time we have to choose either E1 or E2, and this A11 and A22 is nothing but the required time for particular station. So station number 1 here required 7 unit of time and entry gate required 2 unit of time. So 7 plus 2 is equal to 9, and here 8 plus 4 is equal to 12. So this both the value we have to store inside our matrix. Now we have to fill a value of our matrix for the station number 2. This is the station number 2 for line number 1 and value for the station number 2 of line number 2. So as per the equation, when the value of j is greater than or equal to 2, or we can say when the station is greater than or equal to 2, at that time we will have a two option. This is the first option and this is the second option. Among that we have to identify which one is minimum. Same for the station number 2, we will have a two option. Out of these two options we have to identify which one is minimum, that we have to fill inside our matrix. It means that, for example, we are on station number 2 of line number 1. At that time we have a two option. One option is this path, this is coming from the same line, and second path, this is coming from the another line, or we can say line number 2. So we have a two paths to reach on station number 1 of line number 1. Among these two paths we have to identify which required minimum time. So for example, when we choose this path, at that time 7 plus 2 is equal to 9, 9 plus 9 is equal to 18. So when we choose our station number 1 of line number 1, at that time if we choose this path, at that time it required 18 unit of time. For example, if we choose another path from the another line, at that time it required 4 plus 2, that is 4 plus 8, that is 12, 12 plus 2, that is 14, 14 plus 9 is equal to 23. Among these two paths, among these two values, which one is minimum, that we need to identify, and we have to fill minimum value inside the matrix. So 18 and 23, 18 is minimum, so that we have to fill 18 here. Same way, if we check about the station number 2 of line number 2, at the time again we have a two path. This is the one path from the line number 1 and second path from same line, that is line number 2. Among these two paths we have to identify which one is minimum path, or we can say which path required minimum amount of time. If we go for the this path, at that time 2 plus 7, that is 9, 9 plus 2, that is 11, 11 plus 5 is equal to 16. So this path required 16 unit of time. When we choose this path, at that time 4 plus 8, 12, 12 plus 5 is equal to 17. It required 17 unit of time. Among this both the value, 16 is minimum. It means that we have to choose this path, and minimum value we have to store inside the matrix. So 16 will be stored inside the matrix. Same way for the station number 3 of line number 1. We have again two paths. This is the first path and second, this is the second path. Among these two we have to identify which path required minimum time. So when we choose this path, or you can say on same line, at the time previous value of this station was 18, and 18 plus 3 is equal to 21. So when we choose same path or line number 1, at the time it required 21 unit of time. When we choose another path, or we can say the line number 2, at that time the previous value of this station was 16, 16 plus 1, that is 17, 17 plus 3 is equal to 20. So the answer is 20. It means that we have to choose this path, because among these two value 20 and 21, 20 is minimum. So 20 we have to store inside our matrix. When we think about this station number 3 of line number 2, at that time we have again two paths, one from the assembly line 1 and another from assembly line 2. So we have to identify which path required minimum amount of time. So just check for this assembly line 1. So the previous value of station number 2 of assembly line number 1 was 18, 18 plus 3, that is 21, 21 plus 6 is equal to 27. So this path required 27 unit of time. If we talk about the assembly line 2, then the previous value of A22, or we can say the assembly line station 2 of assembly line 2, it was 16. 16 plus 6 is equal to 22. So among this 22 and 27, which one is minimum? 22. So that we have to store 22 in our matrix. Same way, Station number 4 of assembly line 1, we have 2 paths, one from the same line, line number 1, and another path from line number 2. Now for this assembly line 1, the previous station required time for the previous station was 20. So 20 plus 4 is equal to 24. And if we move from the line number 2 to line number 1, at that time the previous value of our station number 3 was 22. 22 plus 2 is equal to 24. 24 plus 4 is equal to 28. Among this, both this value 24 is minimum, so that we have to store 24 in matrix. Now station number 4 of assembly line 2, we have again 2 paths. We can choose one from the assembly line 1 and another from assembly line 2. If we choose from the assembly line 1, at that time the previous value of A12 was 20. 20 plus 1 is equal to 21. 21 plus 4 is equal to 25. Now for line number 2, the previous value was 22. 22 plus 4 is equal to 26. Among these two value 25 and 26, 25 is minimum, so that we have to fill 25 here. Then the last station, that is station number 5 of line number 1. Here again 2 paths, one from the line 1, and the previous value was 24. 24 plus 8, that is 32. So when we choose our assembly line 1, at that time the answer is 32. When we choose assembly line 2, at that time the previous value was 25. 25 plus 2, that is 27. 27 plus 8 is equal to 35. So among these 32 and 35, the 32 is minimum, so that we have to store 32 in matrix. Then last station of line number 2, here again 2 paths, one from the line number 1, and previous station required 24. 24 plus 3 is equal to 27. 27 plus 5 is equal to 32. So this required 32 unit of time. And the line number 2 required, the previous value was 25. 25 plus 5 is equal to 30. So among these two, 30 is minimum, so that we have to fill 30. See, this is the matrix to find the solution of our assembly line scheduling. Among these all the values, we have to identify the minimum value, and we can find the solution. We can find the path which required a minimum time to produce one car. So how we can find the path from this matrix? So now the first step is we have to start from the station number 1. We have to choose station number 1, either station number 1 of line number 1 or line number 2, based on the minimum value. Among these two value 9 and 12, which one is minimum? 9 is minimum, so that we have to choose 9. If you want to choose 9, it means that we have to choose entry gate 1. So our path will be E1 to A11. So the total time required, that is 2 plus 7 is equal to 9. So we have to choose this path. Now we are on station number 1. Now we have to move to the station number 2. Either we can move, we have again 2 paths, station number 1 of line number 1 to the station number 2 of line number 1, or station number 2 of line number 2. Among these 2 paths, we have to choose best path, and that we can identify from this matrix. Among this, both the value 18 and 16, which one is minimum? 16. It means that we have to choose line number 2. This row indicates line number 2. This row indicates line number 1. So 16 is minimum. It means that we have to choose line number 2. So that now our next path will be station number 1 of line number 1 to the station number 2 of line number 2. This is the best path. So we have to choose 16. Now if you want to move on station number 3, again we have 2 options. Either we can choose line number 1 or line number 2, or we can say we have to choose this path or this path. Among these 2 paths, which one is best? That we need to identify from this both the value 20 and 22. So 21 is minimum, so that we have to move on line number 1. So that we have to move on line number 1. So our path will be like this. Now we have to select S4, or we can say station number 4. At that time again we have 2 options. Line number 1 require 24 unit of time, and line number 2 require 25 unit of time. So definitely we have to choose line number 1. So our path will be A13 to the A14 and it required 24 unit of time. Now one thing you need to note it down here, when we move on our last station, at that time we also have to consider the time of exit gate. It means that now we have only one station remaining, that is our station number 5. So either we have to choose station number 5 of line number 1 or line number 2. Before selecting of that, we have to consider required time for the exit gate also, because when we choose station number 1 of station number 5 of line number 1, at the time compulsorily we have to choose X1 exit gate. If we choose station number 5 of line number 2, at the time compulsory we have to choose X2 gate. So that we have to check total time required by the exit gate plus our last station time, and based on that we have to decide whether we have to go for the same line or our another line. So for example, we are on station number 4 here, and our minimum time required by our station was 24 in this case. At that time either we can move here or we can move here. When we move here, at that time compulsory we have to choose X1 gate. When we move here, at that time compulsory we have to choose X2 gate. So let us check both the possibility, and we have to choose either A15 or A25. So when we move from A14 to the A15, at that time it required 32 unit of time. So 32 plus 3, that is 35. So our answer will be 35 to make one car. But when we choose this path, at that time our answer will be 30, and 30 plus our exit gate required time, that is 6. So 30 plus 6, it is 36. So total time required by our car will be 36. So here when we choose this path, at the time required time will be 35. When we choose this path, at that time required time will be 36. So definitely we have to choose this path, right? So when we move on our last station, at that time we have to consider our exit gate time also. So among this both we have to choose 32, not 30, and our answer will be 32 plus X1 is equal to 3, that is 32 plus 3 is equal to 35. So to make one car, to produce one finished car, it required 35 unit of time as per the dynamic programming. So this is all about how we can find a path, or we can say the shortest path to reduce time to make one car. Let us have a discussion on algorithm. We have to just make algorithm for this both the equation, right? This is for the line 1 and this is for the line 2. We have to just convert this equation into the algorithm. So as you know that at initially we have to choose E1 gate or E2 gate based on the E1 plus A11 and E2 plus A21. There is no other choice. So for the line number 1 we have to choose this E1 gate. For line number 2 we have to choose E2 gate, and this is the value of our station. Then after we have a different choice. This is the choice for the line number 1, and we have to choose line number 1 or line number 2 based on this condition. If this condition is true, or we can say this F1 line number 1 is less than or is equal to the line number 2, at that time we have to choose line number 1. Otherwise we have to choose line number 2. Same way for the line number 2. If this condition is true, for example F2j minus 1, A2j less than or is equal to F1j minus 1 plus T1j minus 1 plus A2j, at that time which one is minimum? So line number 2, so that we have to fill line number 2 inside the matrix. Otherwise line number 1. This is just algorithm based on the equation. At the end we have to, as we discussed, we have to consider our exit gate value. So if f1 of n plus x1 is less than or is equal to f2 of n plus x2, this is for the exit gate 1 and this is exit gate 2. So we have to identify which required minimum time, that gate we need to choose, and based on that we have to choose our last station. So whenever this condition is true, at that time we have to choose line number 1, otherwise we have to choose line number 2. This is all about algorithm of assembly line scheduling. So thank you very much for watching this video.